Let's look at an example. The heights of adult men in America are normally distributed with a mean of 69.1 inches and a standard deviation of 2.63. So we're given here the mean. I'm going to write it right up above. 69.1 and the standard deviation of 2.63. This is for the men. So if you need to label it like that, because here we're going to talk about the women next, you could write maybe an M under both of these to help differentiate it. And then when I do the women, I would write a W. The mean for woman is 64.8. And the standard deviation for women is 2.56. So if a man is 6 feet 3 inches, which is the same as 75 inches, for those of you who are struggling a little with that, remember that there are 12 inches in a feet. So when they say 6 feet, you take 6 and multiply it by 12. All right, and that's going to get you 2 inches, and then you add the extra 3 inches. So that's where 75 inches came from. All right, for the z-score, we want to find, remember, I'm going to scroll up just real quick. Z is equal to x minus mu over sigma. So they say here, this is my x. I want to know, where is this piece of data lying in range to the average? Essentially, is this man that's 6'3", is he above average? Is he below average? How much above or below average is he? Well, that's 75 is the data value minus the men's mu, the men's average, divided by the men's standard deviation. And this is what we put into our calculator. If you have your scientific calculator, pull it out and type it in. Try to follow along with me. So I'm going to just do the subtraction first, and I get 5.9. And then I'm going to divide by 2.63. And I got 2.2433. Just going to leave 4 decimal places just to be thorough. All right, remember what's happening here is this is saying that this man is 2.24 standard deviations above the mean. So he's taller than average. What about a 5'11" woman? What's her z-score? Well, again, the z-score is the data value minus the average over the standard deviation. So we take her data value, which is 71 inches, minus the woman's average, right? We don't want to subtract the men's average because this is a woman's piece of data. So minus 64.8, that was the woman's average, divided by the woman's standard deviation, 2.56. And I'm going to do the subtraction first. So 71 minus 64.8. You are welcome to do this in one step, okay? You don't have to show that you did the subtraction first. And we're going to divide by 2.56. And we get 2.4219, and that's rounding that 4th decimal. So this is saying that the woman is 2.4 standard deviations above the average. The reason, or another reason I should say, z-scores are so powerful is because here, of course, the man is taller than the woman, but is the man tall compared to the men's average? He is above average, but the woman here is more above the woman's average. So you'd say relatively, the woman's taller, and that's because her z-score is further away from the value 0. 0 is the mean. So if you have a bigger number, that means she's higher above the average. If you have a larger negative, so if this had been like -1 and -2, well, -2 would be more below average than -1. It's the further from 0, essentially. The woman, because she has a larger z-score. And I'm going to specify that that means she's further above the average, which is 0. or I should say a 0 z-score.